has been around being that tech agnostic person that people can look towards. And that has helped me immensely in that entire journey, not only as a person that people rely on, but also as a product manager who can take those calls for action wherever it is needed, right? So back in upgrad, I was a part of the B2B vertical, where my entire role was around building something for the college partnerships, the clients that we had, allowing and enabling learners up to 200 to 2000 was the range, and building tech for such a different crowd, such a diverse crowd, pan India, was something that I hold very closer to. Post which, right now, I am a part of a founding team of a startup called Xylem.ai. We are into AI infrastructure. I'm building products for the developers. The whole idea is to democratize how we use AI. That's how I usually put it. So the whole idea behind leading product and growth for Xylem is to also build in that culture of, because it's a very highly evolving field. So how quickly can the ecosystem actually go ahead and absorb the new learnings is also a part of what I do. And that's where majority of my socialization kind of happens and helps me, because it's very important to put yourself out there in the ecosystem to actually go ahead and absorb a lot of these learnings, right? Other than that, I'm leading two community initiatives. One is Women in Products India. That is something that's very close to my heart because of the advocate of representation and diversity and inclusion that I am. And I lead another organization called community-based organization called AKIM. So that's something that a little bit in a nutshell about me. Only reason I gave you such a an elaborate introduction is it would be a little easier for you to actually go ahead and relate to a couple of things that I say. You would understand from where I'm coming from, and of course, to give a little bit of a structure to why we all are here today. For me, it's just that when we talk to and get into the space where we're talking about things that make us happy, that excites us, that brings in that passion, it enables us to actually dig a lot deeper and understand those concepts a little more in depth, right? So even before we even go into the session and how and why, how adult learning is very different, right? So I have a very clear understanding in my head whenever I go into why I want to do a session. It's very important that we look back and check that what is that we want to achieve after the session. So think of it just to give a little bit of a structure and set the tone for the session. Consider this as your first masterclass for Gen AI and LLM. So it will be everything that you need for that journey that you are about to take in terms of how you use Gen AI, in terms of how much do you want to get into this field, all of that. We will explore business applications, we will explore challenges, key considerations. How is it like to be a PM in the AI space when it is constantly evolving? And of course, I will give you some sort of resources at the end of this session that will enable you to in this journey. Like I was mentioning, this graph that you see on the screen, it talks about big enterprises and startups and their growth journey, right? So here the very important part to see and understand is how great firms fail in the face of disruptive innovation. When I say fail, failure has a very different meaning when it comes to business impact. How do you put and define failure will depend on a startup or on a big enterprise. And having said that, that becomes your necessary metric that you chase. So, for example, in terms of a startup with limited funds, with limited time, the time to market the product is super less. You have to go ahead and market and start selling it super early, right? So that comes with a fair set of challenges. And for big enterprises with a number of resources and things like that, they have a lot of other challenges as well. They have a brand image to protect. They have to make sure whatever they build actually goes ahead and works very well with everything that they have been doing, works very well in ensuring that customer delight is maintained. They have to work really well in ensuring that whatever time and energy that they have spent there is actually gonna last for a little while, because the decision making processes are a little longer and they take a little more time. So when that happens, of course, that gives us that, like, pros and cons list that you would have to go ahead and think of. Having said that, that is where we need to understand and actually evaluate, do we really need AI there in that particular processes? We understand that AI is a friend. We understand it can do wonders. We understand that it can go ahead and, like, build you something that you could be really, really proud of. But having said that, you also need to evaluate that, is it the right time to do it? Is it the right way for me to go? Is it the right business model for me? Is it what my customers want? All of that comes as that checklist that you would go ahead and, like, figure that out. Only reason I go ahead and share these examples is because we can go ahead and, like, learn about the fundamentals. We can learn about how AI works, but it is also very important at this day and age to actually understand if and when do we need those capabilities, whether or not they are working in the pace that we want them to work, whether or not we actually are given that set of fair chances to actually figure that out. So, with that tone set, with that understanding that AI can do wonders, plus we need to have some checks and balances, let's go on and dive deeper into what we are going to learn today. Let's just go ahead and, like, do this activity. You can use the chat box. You can also utilize the unmute option and go ahead and, like, share what do you think AI is. I just need a one liner. So any two of you or any one of you can go ahead and unmute themselves. Okay. You can just, like, from your rudimentary understanding, what do you think artificial intelligence is? So you can even take them at face value, that what do you think artificial intelligence could mean, right? So if you could, like, you take a stab at it. There are no wrong answers, honestly. The only thing that we choose to learn from the session is actually refining that thought process, nothing else. So go ahead, take a stab at it. If not, you also have a screen shared on the on your systems as well. So you can go ahead and read it also, and you can give me an interpretation. So anything works. Anybody wants to take a stab at it? If not, I'll just go ahead.
Is basically the intelligence of any software or machines as you compare it with the intelligence of humans. If I can read out, it says a program that can sense, reason, act, and adapt. So
Great, great.
it overall takes to that meaning as to human intelligence versus machine intelligence, how it adapts to the learnings and how it responds to it.
Amazing. Thanks for sharing that with us, Arun. So, like, even going beyond that, right? All of the jargons, all of that you think, what can artificial intelligence mean? I feel very overwhelmed. I don't know. Like, when people talk about it, why are people talking about it? All of that into consideration is super valid, because right now, when we think about artificial intelligence, let me break it to you. And artificial intelligence both are services right now. That is how I would place artificial intelligence. They have been there in the past, but right now they have become so empowered to help us out with our problems, with our business solutioning, with everything that we do. Okay, so let me just read out two answers as well. That can replicate this as a human. Fair, fair, pretty fair. So I would, like, I was mentioning, AI is mostly a service and intelligence that is help that is there for us. Think of Einstein being there to help you solve your math homework. That's how I would put AI as your trusted friend, your trusted buddy. And how do we go ahead and put a little bit or like remove a little bit of that fluff and go ahead and design. So it's intelligence, right? How we intelligent humans is a way of understanding when it comes to artificial intelligence. It's so fundamental. It's a way that a computer algorithm goes ahead and solves problems, gives us answers, helps us out, enables us to perform better. That's how I would place artificial intelligence. It is a branch of science that includes machine learning, deep learning, all of the other hooplas that you see. Everything comes around the entire artificial intelligence as a science, right? That is how I would place the rudimentary understanding of artificial intelligences. I would urge you to remember this figure as we move forward, because I will, of course, go into depth a little bit of all of these things that you see. So, going back to what I was gonna say, right? So, whenever we think about these things like deep learning, machine learning, large language model, generative AI, and all of these things that we actually have been seeing floating around, right? What actually comes to our mind is, what is the relationship between this? Why do I need to learn about what happened in the past to know what happened in the future? That is because any new technology that is a part of any new revolution draws itself heavily from all of the old technologies that we have seen. And that's where our this entire graph of how the technological revolution has happened, has occurred, and helped us in this manner that we have seen right now. So when we see the early days of AI, right? So the early days of AI was limited to like limited systems, limited processors. We had very rudimentary understanding of how AI models where how we could actually go ahead and utilize them at this power, at this capacity, because they required extensive coding. It was a very labor inducing process. You would have a team of 15, 20 engineers trying to figure things out for themselves, heavily sitting themselves in the room and trying their level best to make things work, and understanding how things work on a very, very, very bad system like a processor, and the hardware that was available to them did prove to be a little bit of an overwhelming task. But that was the very onset of AI as we see it. So we have machine learning, we have deep learning. These are all sciences that came from this entire set of people, set of machines that enabled us with that technology that we could build on that. So how would you go ahead and define machine learning, right? So Tom Mitchell is a very celebrated author. He has written, given lectures, and I would urge you to actually look him up. The kind of lectures that he provides are super interesting as well as super knowledge inducing, right? So he says machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience. So when you read that sentence, it becomes very clear. Think of it like a baby learning to walk. So the very first day it tries to walk, it falls down. It understands how much time it can stand, and then it does it again, and it improves with experience, with how much time it requires for them to actually go from one place to another. The second day, the third day, they will try to do it. They will hold the furniture to stand up, things like that. Same with machine learning. When you think about machine learning, think of this rudimentary set of algorithms that are trying to help themselves out, trying to understand how to get better, trying to understand how learning through trends, learning through patterns, learning through stats can help them out be better every day. And that's where machine learning kind of takes the precedence. I hope you have an understanding now of how machine learning works. Forget about the jargons for a minute, but I hope everybody is clear on the first principle of what machine learning is. Just give me a yes in the chat box if you can. Great, great, great. Amazing. So, when we think about all of this into machine learning, there are certain things that work as helpers for machine learning, right? So, you would have to think of it as these classifications, the types of machine learning actually help the entire program out to understand how the processes, work, how do we go about. So you might have like this range of information available to you, but not everything is important, and how you consume it is also something that you need to decipher for yourself, you need to understand for yourself. And that is where three types of machine learning kind of takes three techniques of machine learning kind of takes the precedence. So we have supervised machine learning, we have unsupervised, and we have reinforcement learning. So when I told you about going back to the first principle whenever you are learning a new concept, I literally meant it. So you would see this slide is taken from actually an website called teachkidsforrobotics.com. The only reason this is taken from there is the example is set in such a good manner that it allows you to actually understand how simple machine learning can be, how simple first principle learning can be, right? So think of this computer algorithm that you see, the blue cute robot. It has been given these shapes. We have this yellow one, it's called a star. We have this blue one, a rectangle, a triangle, a square, and a circle. So all of these shapes have been given a label. We have given these information as fodder to this particular person, this particular robot, to actually process it. So, what supervised learning actually does is it takes all of the information available to it and then allows you to classify that information into corresponding output labels. So, you would see you might have given it a different star to learn from its behavior, but it also understood that this black one is also a star, this pink one is also a star. Similarly, with circle, you had given it a circle like this, but it also understood that this red one is also a circle and the blue one is also a circle. That is how supervised learning work. You give the algorithm a set of principles, you give the algorithm a couple of labels, and then it understands it very well that, if I am given another set of things that do not, that resemble that set of data that I was provided, they can actually go ahead and understand it and interpret it for you. And that's how the classification here is done. Are you clear about the supervised techniques, how supervised techniques work? Please feel free to drop in your questions. I'll take them at the end of the session, or maybe we can take a small break in between the session as well. Yeah. Please utilize this chat box for the questions as well. Having said that, when I talked about supervised learning use cases, you might also see that there are two types of supervised learning use cases. So you have the classification use case and you have the regression use case. The classification was one is very straightforward, like how we saw in this particular example. You gave the algorithm some set of data, you gave it some set of labels, and now what it does is it classifies that. So here in this example, you could see it classifies all the crosses, all the pluses in one format, and it classifies circles in another format. So it's a very straightforward understanding of how classification does. Regression, however, whenever you look up regression anywhere, it might be a little overwhelming to understand because there is a mathematical formula to it. You go ahead and, like, you might be like, what is the line of regression? I don't know what intercept means. But let's just, like, take a step back and actually let you through regression in terms of an example, because that would actually help you out in understanding that mathematical concept in case you want to go a little deeper. So, for example, we have a car company called Toyota Motors. So, Toyota Motors has been producing vehicles since 1997, and they have been trying to. Their main purpose is to stop the kind of emissions that they have been making, carbon dioxide emissions that they have been making into the environment. The idea is the problem statement is to reduce the carbon dioxide emissions that have been occurring through Toyota Motors vehicles, right? Now, at this point, if you are a manager in this company, some other manager came in and gave you, like your senior manager came and gave you this problem statement, a very well thought out response to that could be, what is that data that's available to me? And that's how data kind of helps us. You can go back and check all of the carbon dioxide emission levels that are available to you historically. So you would have all the cars, whatever carbon dioxide emission levels were there in 97, in 98, and so on. And you could actually understand and plot it in a graph. Once the graph is plotted, you could actually plot it in a manner that what is that ideal technique, ideal map that you would want. So if you like, let me just break it a little more. In the x-axis that you see, you could plot the time, and in the y-axis you could measure the carbon dioxide emission. What happens is when you are plotting it, you can also find the line of regression. What is that? Do you remember how we used to do graphs in the standard 8 and 9? Similarly, the line of regression here would play a role, because that will give you the exact average in between. So you could actually go ahead and figure out. In this case, in this particular example, of course, we know that carbon dioxide emissions are bad for the environment, right? So the line of regression, this pink line, should be negative in an ideal case scenario. So the cars that were produced in 1997 should have a lower should have a higher carbon dioxide emission level than the cars that are produced in 2003, right? That should be the ideal case scenario. Basis of that, you could actually go ahead in 2024, you can try and make a car that actually outperforms the one in 2023. So that's how regression kind of can help you out in solving these problems that you see, helping you with the data that empowers you to make those decisions that are your call, right? Are we clear about the regression example? Okay. I'm just gonna take it as okay, cool, great. Thank you for doing that. Yeah. So moving on to unsupervised learning, right? Similar to what we did in supervised learning, but let's just take it by the face value. Unsupervised learning. What do you mean by unsupervised? Unsupervised is anything that does not require a lot of effort. So what that does is, so for example, here you have the circles, the triangles, the rectangles. This is the data that you have given it, right? You have not labeled it in any way. You have not told that this yellow one could be a star. You have not said that this pink one could be a circle. You've just given this data to the algorithm. But what the algorithm does is, on the basis of its understanding of how these could be placed, it places it in a manner that works the best for it, right? I'm not saying that it is always perfect, but it understands that, what is the actual thing that it could actually place these things at. So you could see that there are so many things that is given to this algorithm, right? But what it has done in the first case, it has clubbed yellow star and a yellow square, a yellow rectangle here, because they are yellow. Same with this first second example, it has clubbed the blue one, the pink circle and the pink rectangle together. But how do you define this, the yellow star and a black triangle? It understood that, a component of triangle is there in the star, so it understood that, let me just label it this way, right? So that is how unsupervised learning could work. So this is just an example. Of course, you can feed it more data. If you could let it know that, I want the stars to be separate. For example, I want three clusters, I want three groups of data, I want stars, I want rectangles, I want triangles. And you tell it that, this is like all of the data that's available to me, and you just give me these three things. It will go ahead and give you that in a very beautiful cluster, and that is where our common use case kind of comes in. So we have all of this raw data that's available to us, right? So we have just given it the raw data. What it has done is, by its understanding, by finding its patterns through that raw data, by finding what sticks, what might be a possibility, what might not be a possibility, it has divided it into clusters. So the cluster one, it is denoted by green, two is by pink, and three is by yellow. So you could see the cluster one, it has divided it in a manner that it understands best. So it has gone through that data, it has found a pattern that suits the best, and it has gone ahead and divided it into these three clusters. All right. Moving on to reinforcement learning, going back to the first example that I took, right? Machine learning, a baby trying to understand how it works, experiential learning, and all of that. So think of reinforcement learning as that reward system that we used to get from our parents if we could finish our homework on time. So we must have had one of those days that, it's a very difficult math problems to solve, and you have been your father has taught you so much, like, this is how you do this problem, but like, you're not able to solve it. After a period of time, your father is just like, what, if you do this problem right in the next 5 minutes, I'm going to give you a chocolate. now your reward increases. Now you have a chocolate in the line. So what you would do is you would try your level best to solve it out. Having said that, that is where reinforcement learning kind of takes its precedence. So in an environment where there is this is a very easy way to understand it as well. So reinforcement learning, it does make decisions, but it also understands from a method of trial and error in that environment that it's placed at, what kind of behavior is rewarding and what kind of what kind of behavior is not rewarding at all. Basis of that, what it does is it incorporates the rewarding behavior and tries to minimize the unrewarding behavior. That's how the entire reinforcement learning principles work. Of course, you can go through the English that's there in here on the PPT. I will of course share this PPT with you, but yeah, the core principles remain the same. In any environment that you place an algorithm, it is going to reward anything that you give feedback that this is right, and it would try to minimize the non-rewarding behaviors. Moving on to what deep learning is. So deep learning, again, we spoke a little bit about in the okay, Arun, you have a
Ye-
question?
Yeah, in the previous slide, you were talking about reward, right? A human
Yeah.
understands what a reward is. For a machine, what would be a reward?
Yeah, so take that example in the form of data, right? So for example, reinforcement learning works a lot with, like, feedback from humans either, or any algorithm that you might have coded, right? So for example, you want an understanding that you have given the machine, the algorithm, a set of fruits. It's a assorted set of fruits. You have apples, oranges, bananas, grapes, and everything, and you have said that give me the data which says that of the fruits that are rich in vitamin C. Okay, so it has given you the data, but the data has bananas in them and oranges as well. But then you go ahead and tell it, like, what, that's not correct. You have given me bananas, but I don't think bananas have that kind of vitamin C. So it understands that it made a mistake, so it goes ahead and, like, gives you oranges in the next result. That is a way that you could think about it. It is a more nuanced conversation, I would still say, but this is how the first principle of it works. It takes in the feedback that you're giving it, that this is not right, and a lot of it right now doesn't incorporate a lot of human feedback. But having said that, there are, like, complex systems at the big back end, which actually enables it to understand what is a correct response and what is not a correct response.
Okay, understood
Yeah.
that. Thank you.
Yeah, no worries. Moving on to what deep learning is. So, deep learning in general, think of deep learning as the closest to how the deep learning mechanism as the closest to how our human brain kind of works. So, deep learning runs in the principles of neural networks. Don't worry, I know neural networks. What is neural network? How are we going to decipher it? Might be a little difficult, a little tricky, but it is not. Neural networks in general needs to have this very core thing that that enables our brain to work. It enables us to make decisions. It enables us to actually go ahead and, like, form these complex decision making processes, form understand what is right, understand what is not right, understand what could be the next task, all of that, right? So think of deep learning and as a principle of neural networks, as that uh, that enables that entire algorithm to make those decisions, to decipher certain challenges, to and you name it, like, all of the applications that you can think of a human brain, you name it, you could actually utilize these complex sets of neural networks to achieve that at the end of the day. Deep learning, again, like we also spoke a little bit about labeled and unlabeled data in the past. It works on the concepts of unlabeled, unsupervised form of machine learning, but where you need to understand the differences. It's not just one unsupervised learning that takes place. It's an immense amount of data that goes into the backend. There is a lot of processes that go ahead and, like, enable that deep learning algorithm to learn from it. So to do all of these complex functions that we see them doing, one thing that keeps that we need to keep in mind, these are large systems, these are things that require time, these are things that require a lot of data being at the core of all of these things that we are learning today. This requires a lot of unstructured, unlabeled data, and that also becomes a huge advantage for us because we don't need to go ahead and label each and everything that you feed into the system. It is very simple for us to do because we are giving them a certain set of responses, we are giving them a certain set of data, and we are asking the system to learn from it. What that does is that saves us time, and it also enables the deep learning algorithm to keep learning through it and make decisions, understand what is right, what is not right, and incorporate all of these functions that we saw in the last use cases, and actually form these complex set of neural networks that enable you to actually go ahead and make that application that we see. In terms of types, I would say there are two kinds of deep learning types. There is discriminative model, and then there is the generative models that we are aware of. Discriminative models, again, they use labels for learning. They are super label heavy. They also will not perform in the way how generative AI models perform, because discriminative models require a lot of structured data as well. So anytime you need, because the main principle for doing deep learning's work is to save us time. It is also because discriminative learn models used to be one of the core models for everything that we saw before Gen AI, because the idea was very simple, that if you're giving it more labeled data, of course you're going to get better responses, right? So if you're feeding the system more information, if you're giving it supervised data points to learn from, of course it is going to give you better responses at the time, right? But with the evolution of generative AI, what we have seen is, though we do not give it a lot of, like, just think of the example of ChatGPT. Whenever you type a query, and if you do not give it a lot of context, what that does is it understands whatever it can understand from your prompt, and then goes ahead and gives you an answer basis on that, right? So that is where we need to understand the capabilities of both of these models. For discriminative models, labels are super important. If you give it good data, it will give you good results. For generative AI models, labels are not that important. You can feed it contextual information later part of the the product that you see, the UI that you are actually going ahead and interacting with, and it will give you results that actually help you out, right? One quick way to actually understand how, if it is, whether the entire product is built on Gen AI or not, is a quick tip that I have also seen is, if it is a Gen AI model, if it is a product based out of a Gen AI model, it will always give you an answer in terms of, which is in terms of things that is easily decipherable. So it will be either a natural language key concept, like, if you ask it what is the national bird of India, it will give you peacock, and it will give you a little bit more about peacock, right? Things like that. If you ask it for an image, it will give you an image. If you ask it for a piece of music, it will give you that. So anything that is easily decipherable easily comes under Gen AI, because what it does is it allows you to generate new content. We will go into a little depth in the next slides so we understand this a little better. Moving towards the applications, I would say, majority of the companies that we see have been using deep learning to actually revolutionize the way they look at tech. We have seen the upsurge of autonomous vehicles, Tesla being one of them. There is language translation software, sentiment analysis. What is sentiment analysis? You could actually understand from a human face. So I saw this software which was super cool. Okay, you could actually see your customer's face while they are, of course they have their consent forms and everything. You could actually see their faces when they are placing their orders. Once the orders are placed, you could actually track the way the customers are feeling. The customers are if they find something that they like, the way their facial expression changes, all of that. So you could see all of that through that, and you don't even need a human intervention. You could actually have deep learning models in the back end running through it, actually understanding how they are feeling about it. Having said that, it's the same way the same way emojis also work. So you must have seen, how Amazon has like the star based rating system. In certain apps we have these five emojis, starting from the sad face to a very delighted face. That is also a way that companies track how delighted we are to actually use that product. We can do like a sentiment analysis at the end of the day, if people are feeling happy about the product, if they are not. All of this comes under that, right? So this is one of the key applications of deep learning. So the only reason including this in this manner is because, of course, there are a lot of tech applications, but we non-tech folks are we need it as much as the tech folks do, because that enables us to actually understand what more can we do. Is there something else that we can try out for our product? Will always help you out in understanding if you could innovate in a manner that saves you time, that saves you cost, all of that, right? Moving on to neural networks, like like I was mentioning, neural networks is the most important part of this entire neural network process, right? So all of this I kind of covered. So I'll just go ahead and give you this particular illustration. Think of it as the human brain. It takes in information, it takes out information. For neural networks in deep learning, they process information in terms of numbers. So, for example, you have a text, you have an image, you have a video, audio, whatever. It assigns some numbers to it. It goes through the deep learning model, and when the numbers are out, they are given to you in the form of a text, image, or a video, or a audio, right? So, but in this case, now you might ask, what is the difference between, if you see the older models, and how is it different from generative AI, right? Generative AI mostly works as a next word predictor. Just think of it this way for the sake of this example. So you might give generative AI model dogs are, and just leave it at that. The next word it thinks of is animals. Then you put it as dogs are animals. The next word it thinks of is that. So, this is just an example of how things work at the back end of a generative AI model. And you need to understand all of this that I say is happening right now is happening at trillions and billions of speed, back end of a generative AI model. There are interconnection of a large number of neural network models that is there. There are deep reinforcement learning, deep learning models that are employed in the back of it, which are essentially doing this, but at a speed that's not imaginable by the human mind, right? That's how we would position it. This is like, just going back to fundamentals of how Gen AI works at the back end, right? This is how it does from a very first principle perspective. As we go towards this generative AI discussion, this is a good segue into understanding how generative AI kind of came into the picture. What does generative AI mean? So see, generative AI has become a buzzword which actually helps us, do everything, like generate images, generate text, help us with coding, help us make PRDs, help us make rap songs, helps us make paintings, you name it, and it does it, right? So how do they actually work, right? So that's something that, all of the fundamentals that we read in the past, all of that comes towards and inclusively makes up for what we know generative AI as. It's an assimilation of all of the things that we have learned. The fundamental principle still remains the same. It learns from the patterns, it learns from the data that you give it, and it generates any new form of content that you have asked it to generate. That's how generative AI should be placed in your head. It is that model that is outperforming all of this things, taking concept from each of these learning principles, understanding what works the best for it, and actually utilizing it to make sure that it follows patterns and it generates new content basis on that patterns. And again, the basic difference between a discriminative and a generative AI model would be it can create unique and original content on the basis of whatever you provide it, right? So that's something. And again, unique and original can also be debated, because of course if you are giving it a lot of data and you're asking it, like, you gave it a some like a data of like, gave it a book and you asked it to summarize it, just because you got the summary, that doesn't mean that you wrote that book, right? So of course unique and original can be debated, but having said that, here unique and original means that it is not similar to what you have given it. It has thought about it, it has contextualized it, and it has given you the answer that you have asked for. That is how generative AI would be placed. We are little like, a little bit slower on the end of, like, finishing this. I would just ask a good way to, like, actually do a time check. Would you folks be okay if we go over time for like 5 to 10 minutes, like Sahil and everybody else as well?
Yeah, I think that should be fine. Not a problem.
Yeah, great, great, great. Amazing, amazing. Thanks, folks. Yeah. So now let's talk about all of this that we spoke about, right? That we have text to text. Like, here we see generative AI model types. I have been focusing a lot on, like, what you feed as input and what you get as output, right? So think of it this way: whenever you have, like, take ChatGPT for an example. Only reason I'm taking ChatGPT is because some way or other we have used it in some way or form, or at least know how it works, right? So ChatGPT in general, if you ask it a question, it is going to give you an answer. GPT-4 again, if you go ahead and, like, just a sec. So Sahil says most of the current Gen AI models keep context and thus can remember not to be repetitive. Good point. I would say this would be something that still is in work in progress. I see 2024 to be a year where we see a lot of these capabilities being developed in a manner that that actually does things that it says, right? Though it is not repetitive, as we have seen, like, for 3.5, the repetition, the hallucination has come down much lower in GPT-4, but it still requires a lot of work. So capabilities is something that we are always learning on. So good point, Sahil. Thanks for adding that. So Gen AI models, right? Gen AI model types, right? Here, the entire idea is to understand. It's a very self-explanatory activity. When we say text to text, what do you mean? Text is given as input, text is given taken out as output. Same with text to video. Text is given as input, video is generated out of it. Similarly, we can do a number of things when you go ahead and, like, feed text into it. Do you know where it started? It started when Sam Altman kind of went ahead and understood that you don't need to know coding end to end to actually speak to your software. That's how this part of revolution kind of began. And that is where natural language processing also began, right? So the core principles start from a very identifying that very small problem that you see, and then building on top of it. That's where that entire first principle understanding is very important. So even when it is not a very, like, of course this is very self-explanatory, but it is important to understand that AI driven generative models are only, of course, based on whatever feedback that you give it, and AI driven models are heavily dependent on whatever prompts that you give it. So you cannot give it a prompt of apple and expect an orange until you have said that, I until you have hinted that you might be okay with an orange, because it might just say, you can see, ask it to do a job, like, you could say things like, generate a video where I could see Bangalore in February with spring flowers all around the city. So it would learn from the other images that are available on the internet and give you the image. But that doesn't, and there is a high possibility that you would see a lot of bougainvillea flowers. But did you want bougainvillea flowers is the context that you would have to give it if you did not want given bougainvillea flowers. I hope I'm making sense here, because it is important to understand there is an contextual understanding that we as humans provide, and that becomes a feedback. Arun asked in the last example, in cases of like reinforcement learning, how does the machine understand? So now try and relate that here. um, when you give the first prompt that I want an essay on my pet dog, right? So that prompt gives an understanding to the generative AI model, that, and it generates an answer to that. It can give you a very generic pet dog as well. Now what you do is, in the next prompt you write, I want an essay on my pet dog, which I had at when I was uh, in the 12th grade. It was white in color, it had pretty eyes, it had a long tail, it was very cute and cuddly, right? So you give so much context to the generative AI model. Now it knows what you want. Now the context is very clear to it. So the kind of responses that you would get out of it would be something that is super rewarding. That would be something that is very close to what you might want, right? So that's where this understanding is required. Moving on to what are the applications of Gen AI, I will not go through the slide entirely, but yeah, I kind of covered this in the very beginning, that you can go ahead with content creation, generation, you can go ahead with prototyping, financial fraud detection. In gaming, there are super amazing use cases coming up nowadays. So this is something that you can go ahead and utilize applications in places where the world is your oyster, honestly, when it comes to Gen AI applications. One of the major parts of the Gen AI learning has been the introduction of large language models, which are very cutely abbreviated to LLMs. It is also a subset of deep learning. Now you need to understand that why are these called large language models? Again, like any deep learning use case, these are trained on vast forms of data. The idea of LLMs are very simple. Very simple. It works with unsupervised generative pre-training. So there are three concepts that we learned in the past, and all of these three concepts come together when it comes to LLMs. You have your unsupervised learning, you have your generative context, and you have your training. How do you go ahead and do that? Now, unsupervised learning, we all knew how we do. We all know by now that how we do unsupervised learning. Generative means the ability to create and produce new content, and training means, of course, enabling all of this in a process. That is how LLMs are built. One of the major important parts of LLMs is the contextual understanding of LLMs is far better than all of the technologies that we have seen in the past, and it allows you to actually create for domain specific knowledge. So for example, when we saw all of these models, one challenge that we used to face was the kind of adaptability that every one of these models had. So for example, you had a model for model heavily specifically built for a hospital use case or a finance use case, right? But then when you wanted to use that same model in an edtech use case, it might be very difficult to do it, right? But for LLMs, that's not the case. The way they are trained is like, take ChatGPT for example. They're trained in billions and gazillions of data points. You ask it a question of science, it knows it. You ask it a question of humanities, it knows it. You ask it a math problem, it knows it, right? So domain adaptability, the concern of all of that, does not remain a problem anymore. So it allows you to, like, it holds your hand where you don't have to worry a lot about giving it a lot of specific knowledge bases. All of that could be done through and through while you're prompting it, right? Moving on to how they are trained, majority of it is something that I covered while I was talking about Gen AI. Here you would see there is a important word that we will learn here today, that is back propagation. So propagation in general means moving forward, back propagation is going backwards. So I like I mentioned, right, the early days of AI, there was just like so much coding, like everybody sitting there coding up models and like doing things, doing X things. But right now, with the capabilities of generative AI, what has happened is the model that you build is not only just capable of uh, doing X, but it can do X plus plus. So that enables you to capture more of the market. It enables you to capture majority of the things that you wanted to capture. It enables you to do 700 billion things. So it enables you to be that help that you need without putting in more manpower, without putting in more technological resources. What it does is, you just go ahead and, give it unsupervised generative training and train it on billions of parameters. How do you define parameters? If you want, for chat gpt, there is no clear differentiation of parameters. It has, started getting into the parameters learning very recently. It For it, the parameter is, don't give out information that's harmful to human beings, don't give out information that might be harmful to the society. Things like that could be the parameters. But again, gpt has its oysters. gpt has its world as its oyster. Say, having said that, the parameter could also be, in cases where sensitive information is fed into the system, uh, you should not give out that response. In certain cases, that might be a thing. So, if it is a medical based LLM, right? So, if you give out patient information is traditionally the most important, most volatile data, most confidential data. If you train a model on that, it requires number one, consent of that person. It requires HIPAA guidelines. It requires the help from governments. It requires understanding of the laws and ethics of this entire medical domain, things like that. So those could be the parameters for an LLM that is trained on hospital data, right? How do you make sure? Here, back propagation can be easily correlated with reinforcement learning. Now, the idea is, the parameters get automatically tweaked as we go ahead with the entire learning and unlearning process, right? So, like, take an example of the one that I gave you right now. Write an essay of a dog, right? It's a very generic statement. When you add context to this generic statement, those work as your parameters. You allow the model to understand that I am looking for a dog, like I am looking for an essay that has the dog. When I was 12, I was in the 12th grade, and it was white in color. So the model understands you are not looking for a dog, you're looking for an essay of a dog which is black in color. It's not golden in color. It's, you have set a level of parameter with it. And that is how back propagation kind of essentially works. You give it some form of information that enables it to understand and tweak itself in the next one. So it also, so you need to understand, this is just an example of human based work, back propagation, where you're giving in more information. In the back end, there might be algorithms that are helping them out in understanding what works as a rewarding behavior and what doesn't work as a rewarding behavior, right? So that is called back propagation. And of course, no LLM can work without human feedback. I'm just putting a more English to it, I would say, and a more scientific term towards it. So all of the human feedback that we see, that the LLMs learn from, is called reinforcement learning with human feedback, RLHF. That's something that has been super helpful for LLMs to understand contextual information, understand demographic information, understand to be culturally sensitive, things like that, right? So this is something that is machines could not have learned unless we stepped in to make it understand that, you know what, this is not right. You cannot call people this. You cannot give out this information. This is not something that we talk about. This is not something that is beneficial to the society. Things like that, right? Post which, this is how, any general, the first 4 points is how any general LLM would be trained on. Post which, it's open for fine tuning. Now, fine tuning in general, how does that work, right? So your pre-trained LLM can come off as a box, like a packaged box, with all of these capabilities. You have text classification, you have question answering capabilities, you have document summarization, text generation, all of that. So these are, very general properties that you would see. When you talk about these general properties, you can utilize all of this in any field, right? But if your model is trained on industry specific data, what that does is it enables you to make better decisions and more accurate decisions. So here I would urge you to think about two cases. In the first case, you have one LLM that is trained on everything, all of the cases that you can think of, retail, finance, education, all of that. And you have another LLM which is trained on very specific set of instructions. So in this example, let's take finance. Now if you ask a financial question to both of these, the LLM1 and LLM2, what do you think would give you the better answer? Can you write it in the chat box? What do you think would give you the better answer? LLM1, which is trained on generic data, or LLM2, which is specific data, industry specific data? Just type one or two. Great. We have started getting answers. Great. Great. Of course, it is LLM2, because LLM2 in general has more specific information. It has very clear understanding of what you mean by it. When you're asking an information, it understands you very well, where you are coming from. That's the context. And it also understands the data very well. That, okay, this is what it is, and this is what I am supposed to stick to. I am not going to hallucinate. I am not going to think about anything else. I'm going to take this financial use case and I'm going to give you a financial answer, right? So that's where LLM2 works. I'm very glad that guys are now able to relate to all of that we have learned, and you could give out these answers. Thanks for sharing that. This is the LLM example that I was talking about. For example, now let's put a problem statement to it, right? So you are working at a hospital as a hospital technology manager, right? Ex hospital technology manager. Now your manager has given you an understanding that we need to have this bot in place which helps us with diagnostics, right? So people can get in, like, type in their symptoms and they can get out a diagnostic, the initial diagnosis of what their symptoms mean, right? So I could go ahead and, type it for the user. It would look like this. I would go ahead, like, I have headache, I have a runny nose, my throat itches. So it gives me a set of, like, these options that you might have a cold. It's flu season. It thinks about it. It contextualizes that information. It thinks that, okay, it's the month of January, and of course the season is trying to change and it's super cold in certain areas, and it understands that you are in a winter month, so you might have a cold, right? So the what the hospital does is it enables the entire, how would it look for the person who is building it, right? So you'd enable that LLM to understand from the past data. So you have these softwares and the websites called WebMD and others, which who talks about all of the symptoms, what are the cases, what are the, the kind of symptoms that you should look out for, preventive measures, things like that. And you train that LLM with that, all of that older data, the traditional data that is available to you, and all of this other data that's available on the internet. Now you have trained that LLM with very industry specific information. Now, if I go ahead and get the initial diagnosis done, it can also, of course, help me out in understanding and doing a differential diagnosis with the doctor, right? So, when I talk about differential diagnosis, you might have four different closest ailments that you might be looking at. And in these four ailments, the doctors can actually go ahead and give you that understanding that, what, the first two might not be the case. Let us try and do these first, last two, 3 and 4. Let us see what you have, right? So that kind of helps and saves time. I would still say it is super early for healthcare data to be doing all of this, but I don't think it is that far out in the future, because at the pace at which LLM technologies, SLMs are also coming into the picture, it is not very far away that we would see all of this. Another example that you could actually take home with is, I would urge you to, think about a fraud detection mechanism. So for example, it is a bank. How do you go about detecting fraud with generative AI technology? Think about it. Once the session is done, maybe you come up with greater solutions. Having said that, we have these we spoke a lot about models. All of this have been, the talk of the town. We have Llama Index coming up with Llama 2, Llama 3, Cloud. We have Claude, we have Mistral, GPT-4, Zephyr, all of this, right? But the one important part of everything that we do, right, is to understand that first principle that we spoke at the very beginning of the session. Why do we want to incorporate this, right? So of course, LLMs in general are easy to use. They can be specialized. They can be integrated with the businesses that you do. But when you are making a choice into including an LLM into building products for your customers using any of these LLMs, it is very important to go about and look at the speed, how fast the LLM is, how much time it takes to do a certain thing, how much does it cost, can I get a better cost somewhere else, because at the end of the day it is a business decision. So you can also think of it in a manner that it's your very own pro and con list. So you can go ahead and understand what your problem statement is and actually back propagate and feel that and actually note down all of the things that help you out here. Is it speed that I'm looking for while solving my user's problem? Is it the capability of my business that I want to increase? Is it the cost that I am bothered at? So all of these play a huge role, right? And of course, here two more important things while understanding LLMs would be inference speed and latency. Whenever you look up inference speed and latency on the internet, what happens is they tell you that it is a measure of time. So both of them are measures of time, definitely. But let me just give you a small tip here, and you can understand it a little better when you do a little bit of like self reading later. Inference speed is a very singular thing. So for example, you give it one query, dogs are, like in that last example that we took, dogs are, and then it gives out animals, right? What is that time it takes to give out that output is your inference speed. So it is measured with a singular data point. And in case where in cases of latency is the number of the volume of data points it can serve in a particular measure of time. So it's not singular. So for example, in 1 second, how many questions can it answer could be a thing, right? What is that time it can process? So you have 7 queries. Can your LLM answer all of these 7 queries in that particular time, or is it slow? That's how you would decipher your inference speed and latency, right? And of course, how do you go and choose yours? Like I mentioned, this is more of a little bit elaborate understanding of choosing your own model. What do you think? What do you value the most in terms of choosing your own model? What is the task that you are trying to do? In cases where, when we are dealing with e-commerce websites, the accuracy of that model might not be your top-notch priority. You would want the model to be super fast, because if the app is not super fast, think of Mintra. If you are searching in their AI assistant that I want a red color sweater with pine forest on top of it, it should have a Santa Claus on the back of it, things like that, and it is taking 1 minute to actually process that information, give you that answer, that risks a lot of like drop offs there. And as a person who wants to retain customers, that might be a very difficult experience to have. In that case, the other side of the spectrum would be thinking about these healthcare professionals where accuracy is number one. You need to understand that if the models are not accurately placed, they are not giving out right information, it might be a little difficult to use that model ahead, right? So you need to understand that what is that pro and cons list that I have to make at the back of the at the end of the day. In case you are not then you have to calculate that do I go ahead and do make this model, do I use this model for my work, or do I not do that, right? Having said that, I think this is where it all brings us together, is where I see businesses, product technologists, and researchers being at the the exact overlap of where we can move from denial to positive mindset and panic to positive mindset as well. So as I talk to a lot of AI folks, people and businesses interested in AI, there might be two different kinds of mindsets that you might see. There might be people who would be like, what, AI is not going to take my job. It's like, it's just there. It's a passing cloud. uh, didn't you see what happened to older technologies? It's just gonna go. And then there is panic as well, like, is AI gonna take my job, things like that. And I would say neither this or nor this is the right way to look at it. You have to place yourself somewhere here in the middle. You need to understand that, you know, AI is your that trusted colleague, your trusted friend that helps you do things better in that limited amount of time that you have. It enables you to make better decisions, and that's where majority of the why do I use AI kind of takes place. That is where majority of these technologies that you are trying to learn, you're trying to understand, becomes a little easier for you to understand, because you now know what your goal is. You want to become that integral part of AI's ecosystem, that you are complementing each other in every part of the way. And that's where you should place yourself. And this is like, of course I had to include this slide because PMing in AI landscape, I won't say it's hugely different, but I would say the technological implications increase a lot, because when you are in a part of this journey where your technology that you work for changes every day. Actually, there was a period of time back in 2023 July when I actually started working with AI. There was a new model coming out every 3 months, every 3 weeks, right? There was a time in that entire period where there were new models coming like every week. So I remember being at a talk, and after coming out of that talk, I Mistral had launched their model as well, right? So it is important to be very close to the basics. It is very important to understand that, the business applications are as important as the technological applications. There is no time right now to actually, segregate these and think about this together, separately, because the technological revolution demands that from us. So in the space where you want to build AI products for people to be enabled, your users to be happy, it is very important that you are very close to that tech. You do not need to know the very nitty gritties of how things are done, how much tech you need to know, all of that. That is the beauty of all of this, the natural language processing. That is the beauty of generative AI, and that is the beauty of all of the LLMs, SLMs, everything that's coming into place, because everything is done in a manner that, anybody with a rudimentary understanding of tech can actually go and understand these things and work things out. I will share this with you, so you can actually go ahead and, we spoke a little bit about all of this in this entire session. But yeah, being tech agnostic helps you a lot. It enables you to hyper personalize things. Of course, if it is a generic gift, I would might not be that happy. But if it is very specific to what I like, I might be more happy, right? Think of that when you think of your customers as well. When you are meeting your individual user needs, it is very it is a delight factor for your users. So AI helps you do that as well. And this is just like, just to like give you a little bit of an understanding. Not everybody is going to be building AI products. Not everybody needs to build AI products, honestly. But you need to understand how it looks for your user and how it looks for a product builder, right? So this is a very simple example. This is you we usually, when we are using a product, an AI product like a chat GPT, we are not using the model in itself. We don't need to worry ourselves with the model. We don't need to worry if it is a GPT-4 or a llama model. We need to just worry about using this product's UI, right? So that is the major difference between UI, between using a product and building a product. When we are building a product, it is important to understand that the product teams, the business people, the technologists, and everybody in that engineering team, the research team, and everybody are equally responsible in making all of this work, right? So think of it this way. This is your product's UI, right? So the product's UI might be done by the design team, the front end developers. The back end would be done by the back end engineers, ML engineers, data people. There will be other people who are working towards making sure it's cloud agnostic, things like that. But having said that, integral part of all of the information that you receive from this product comes from the users. What are the prompts that you're giving in, and of course the data that you have trained the model at. So I would urge you to think of it this way. If you're using an edtech platform, if you're building for an edtech platform, for example, you can add a chatbot that could actually go through the scroll of your this catalog of your courses and give out results that, if a user comes to your platform and searches, hey, you know what, I have the background of engineering, I know data a little bit, what do you think can I do from this particular courses catalog that you carry? And the model, what the product, what it does is it gives you the information. This is how it will look for your user. How it will look at the backend is the data that you have given the product is from your catalog. The model is already trained on your specific data. There is an API connecting the model and the product, so the user gets the information that they need. Right? This is how the entire ecosystem would look like when you are building and using a product. And these are the, the questions, like the basic material that I wanted to share. So of course I'll just share this with you. I, this kind of concludes what I wanted to share with all of you. And yeah, thanks for being here.